In the 1970s, the Dalai Lama claimed that mere thought could change our brain structure. Even without the aid of modern brain scans and fMRIs, Western scientists knew that this was ridiculous. While it might be comforting to believe our brains can change, they said, it was only a myth. And certainly, if the brain could change, it couldn't do so through mere thought or force of will alone. For most of the 20th century, it was a commonly held notion in the most esteemed research circles that after adolescence, our brains were fixed and unyielding. Neuroplasticity, the idea that the brain is malleable and can therefore change throughout our lives, was essentially the Western unicorn. A few years later, some researchers began discovering tracks of what they claimed was this mythical chimera. This time, scientists found clues not in the skull of an okapi, but inside the skull of a cabbie. Researchers were studying the brains of taxicab drivers who lived in London. Small wonder scientists get mocked at dinner parties for their overly specific research subjects. They found something previously unimaginable. The cab driver's brains had significantly larger hippocampi, the brain structure devoted to spatial memory, than the average person's. Why would this happen? To learn the answer, I went to the source, a living London cabbie. He explained to me that streets in London are not based on a grid system like much of Manhattan or Washington, D.C. As a result, navigating London is like navigating a Byzantine maze and requires that the driver have a vast internal spatial map. It's so difficult, drivers are forced to take a navigational test called the Knowledge before being licensed to drive one of the city's famous black cabs. Who cares? While a bigger hippocampus may not seem exciting to you, it forced scientists to confront the myth of neuroplasticity, that brain change is possible depending on how you live your life. Faced with this data, a scientist who held rigid to a fixed state brain model, which said that your brain does not change after adolescence, would be left with an awkward choice. Either he would have to argue that A, from birth, some people's genes develop a larger hippocampus because they know that they will one day grow up to become taxicab drivers in London, or concede that B, the hippocampus can increase in size as a result of many hours of practice driving a taxicab in maze-like surroundings. As brain scans became more sophisticated and accurate, more tracks of the mythical Western unicorn kept appearing. Imagine someone we'll call Roger, who could see normally growing up, but then suddenly lost his vision after toxic chemicals were splashed in his eyes during a high school chemistry experiment. After the accident, Roger was forced to learn how to read Braille, which required him to use his primary index finger to feel every word he read. When neuroscientists put someone like Roger in an fMRI machine to scan his brain, they made some startling discoveries. When they poked at the index finger of Roger's non-reading hand, nothing out of the ordinary happened. A small part of his brain would simply light up, just like it would if someone tapped on any of our fingers. But then came the extraordinary part. When researchers tapped on Roger's Braille reading finger, a relatively enormous area of cortical mass would light up, like a halogen lamp clicking on in his brain. To explain this, scientists again were left with two options. Either A, from birth, our genes are smart enough to anticipate a freak chemistry lab experiment and thus arrange for a well-hardwired index finger on just one hand. Or B, our brains change in response to our actions and circumstances. The answer in both cases above is obvious and inescapable. Brain change, once thought impossible, is now a well-known fact, one that is supported by some of the most rigorous and cutting-edge research in neuroscience. And the implications are far-reaching. Once our brains were discovered to have such built-in plasticity, our potential for intellectual and personal growth suddenly became equally malleable. Studies have found numerous ways we can rewire our brains to become more positive, creative, resilient, and productive, to see more possibilities wherever we look. Indeed, if our thoughts, daily activities, and behaviors can change our brain, the great question becomes not if, but how much change is possible. What is the longest sequence of numbers a person can remember? How tall can a human being grow? How much money can one make? How long can a person live? The Guinness Book of World Records lists many of the greatest records set, the greatest potentials ever achieved. But the Guinness Book of World Records is a fossil record. It speaks only to what has been done, not how much can be done. That is why it has to be constantly updated. Records are forever being broken, so it is forever out of date. Take the fascinating case of the British middle-distance runner Roger Bannister. In the 1950s, after rigorous testing and mathematical computations of the physics of our anatomy, experts concluded that the human body could not run a mile in under 4 minutes. A physical impossibility, the scientists said. Then along came Roger Bannister, who in 1954 seemed to have no qualms proving that it could in fact be run in 3 minutes, 59.4 seconds. And once Bannister broke the imaginary barrier, suddenly the floodgates opened. Scores of runners started besting the 4-minute mark every year, each one faster than the next. How fast does a human have the potential to run the mile, or swim the 100-meter, or complete the marathon today? Honestly, we don't know. That is why we hold our breath during every Olympic competition, to see if a new world record has been established. The point is, we do not know the limits of human potential. Just as we can't know the limit for how fast a human can run or predict which student will grow up to win a Nobel Prize, we still don't know the limits of our brain's enormous potential to grow and adapt to changing circumstances. All we know is that this kind of change is possible.
Thank you for watching. Please like, subscribe to our channel,